Now, most cooling systems have 5 basic components: the coolant, the water pump, the thermostat, which regulates coolant temperature by controlling the flow path of the coolant, the radiator, and the fan. The system functions by transferring heat from the engine blocks, cylinder heads, and other areas of the water jacket system to the coolant, which is circulated by the water pump. The heat is then dissipated from the coolant to the air surrounding the radiator. The fan improves heat dissipation by either pulling or pushing air through the radiator. Let's talk a little bit about the content of coolant. To perform properly and protect the engine, the coolant must be a balanced mixture of several items. It must have the correct heat transfer properties, prevent rust and corrosion, not produce scale and other deposits, be compatible with all engine and cooling system components, prevent foaming, contain certain appropriate levels of buffering agents which can neutralize acids, and maintain a slightly alkaline solution. To achieve these results requires the correct mixture of water, antifreeze, and corrosion inhibitors. Let's talk a little bit about water. It's an excellent heat transfer agent, but used alone it would quickly corrode the cooling system and engine components. In addition, water's boiling point is too low to prevent boilover in most engines, and its freeze point makes it impractical in most regions. Even as part of a balanced coolant mixture, some tap water may not be appropriate for cooling systems. The concentrations of chlorides, sulfates, total dissolved solids, and total hardness must not exceed the maximum levels shown here in parts per million. Furthermore, water must have a pH of between 5.5 and 9.0, and you should never use salt water, water that's been softened by sodium, or water containing sediment or other foreign debris. Some equipment manufacturers recommend the use of distilled or deionized water. Okay, assuming we have the proper water quality, the next important ingredient is antifreeze. Antifreeze not only protects the engine from freezing, it also raises the boiling point of the coolant. The most commonly used antifreezes are ethylene glycol mixtures. Recently, propylene glycol products have become more available. Regardless of which mixture is used, the important thing about antifreeze is the concentration. It should be between 40 and 60%, with a 50% level being optimum. Under concentration of antifreeze will not provide the proper coolant freeze or boil point. Having too much water and not enough protective chemicals in the solution can lead to extensive coolant system corrosion. Rust and scale deposits formed on heat transfer surfaces accelerate corrosion and increase engine and coolant temperatures. Under concentration of antifreeze can also lead to water pump cavitation, a process in which air bubbles implode and destroy the protective oxide film on metal parts. Over-concentration of antifreeze, that is above 60%, presents its own set of problems. First of all, too much antifreeze actually decreases the freeze protection of the coolant. Since antifreeze can't dissipate heat as effectively as water, the result is higher engine temperatures and possible overheating. Too much antifreeze also tends to thicken the solution, which may cause poor circulation and overheating. Other problems include an overabundance of dissolved and/or solid chemicals in the coolant and cooling system, and also silicate dropout, or the formation of silicate gel, which can plug coolant passages. Sodium silicate, by the way, is an additive to coolants which prevents aluminum from corroding. Dropout and gel formation can occur when there is an overconcentration of antifreeze or when using high silicate antifreeze. For this reason, heavy-duty engine and equipment manufacturers recommend that only a low silicate antifreeze be used at a 50% concentration level. Well, now, let's talk about the age of your antifreeze. When antifreeze is 2 years old, whether in use or in storage, additive dropout and chemical sedimentation can occur. Furthermore, during use, antifreeze slowly breaks down, forming corrosive acids. The coolant also becomes contaminated with dirt, combustion byproducts, and oils. So when coolant hits 2 years, 240,000 miles, or 6,000 hours of service, engine and equipment manufacturers say, change it.